Hello, my name is Zach, and I'm going to be presenting on some work I did with a few collaborators today. And what we're interested in looking at is how spiteful behavior can spread throughout a system. So I'm first going to introduce what spiteful behavior is and what existing models have to say about it. Then I'll introduce how our model is different in its key results, and then I'll sort of summarize everything at the end. So spiteful behavior is an instance of a behavior that harms both the aggressor and the victim. And a key point here is that, say, when two animals are fighting for territory, both are hurt in the short term by the fight, but at least one animal wins the territory and then increases their long-term fitness because of that. Here we're describing a situation where there are no long-term benefits of the short-term aggression that hurts both parties. And so a natural question would be, why would a behavior that reduces the fitness of both parties ever emerge in a system? That doesn't seem to jive with our thinking of how selection should occur. But despite this, we see cases of this costly harm in both humans and non-humans. And a good example of this is for humans is that in laboratory experiments with young children, if they are offered a very unequal payoff where they get only a little bit and someone else gets a lot, or the option to have neither party get any payoff, young children will choose to have neither party get any payoff. So this is something that's ingrained in us at a very young age. And so this behavior that seems contradictory to sort of our natural thinking on evolution has prompted a lot of models to try and explain why this behavior exists. The game setup you can use if you want to investigate this type of behavior has you suppose that two individuals interact and they have the opportunity to pay a cost to inflict a harm on the other. And so under this payoff matrix you see below, if two spiteful agents interact, neither receives any payoff. But if a spiteful agent interacts with a social agent, the spiteful agent receives a payoff of B, which is higher than the social agent's payoff of C. In this game, however, the very best payoff you can get is for, as a social agent, to interact with another social agent. And the key thing to notice is that regardless of what your interaction partner's strategy choice is, your best possible strategy choice is always to play the social strategy. And so because of this, when interactions are random, the social strategy strictly dominates the spiteful strategy. Interestingly, previous work has shown that in a repeated game, spite can emerge if interaction patterns are anti-correlated. Anti-correlation describes when an individual is more likely to interact with someone of a different strategy type, in this case, a social spite interaction, than 50-50 chance. And so the way this is measured is that a correlation of R means that with probability R, an individual interacts with someone of the same strategy type, and with probability 1 minus R, they interact randomly. Anti-correlation is just the inverse of this, and would normally be denoted with negative R, but that would describe a situation where an individual has an R probability of interacting with someone of the different strategy type. Previous work has introduced correlation into their models through a couple different mechanisms. One is negative relatedness, where each individual has some genetic characteristics, and then based on those genetic characteristics, you would be more likely or less likely to interact with other individuals based on their genetic characteristics. Greenbeard effects, where there's some external cue that agents can use to determine their likelihood of interacting with different agents. Spatial structure, so just what are the strategy types around you. Small populations, and then others have also been used. But the key with all of these different mechanisms is that they're requiring some sort of exogenous assumption that is fixing the correlation patterns and the likelihood of the different interactions. Our model differs from previous works because correlation is endogenously produced within the model, and it provides a mechanism that could explain why we see correlated interactions in real-world systems. Specifically, reinforcement learning is used and allows agents to gradually, over time, learn to play the other agents they do best against. Imitation learning also allows agents to update their strategy if other agents are using strategies that are performing better. And this provides a coevolution of both the network on which the game is occurring and the strategies that the agents embedded in the network are using. Here's a figure that depicts an overview of how our model works. So agents are placed on a fully connected, directed network, and in a random order in each time step. Every agent chooses one other agent to visit, and blue agents always play a social strategy, and red agents always play a spiteful strategy. There's also a small tremble that may cause either type of agent to play a random strategy. If we look at a specific example here, suppose that agent 1 chooses to visit agent 3. Agent 1 is a spiteful agent, and Agent 3 is a social agent. That means Agent 1 will receive a payoff of B, and Agent 3 will receive a payoff of C. After they've received these payoffs, Agent 1 will add the payoff of B that they received to their link weight going from themselves to Agent 3. After each agent has gotten the chance to visit someone in a round, independently at the end of the round, each agent may consider imitating another agent. If an agent chooses to consider imitations, they select a possible imitation partner based on the outgoing link weight from themselves to that person and the incoming link weight from that person. And if that partner has received a higher average payoff than them, then they will choose to imitate their strategy. Here is the model written out in word form. And again, just to highlight the key things. Each agent gets a chance to visit someone in each round. And then at the end of each round, agents may imitate someone who has done better than them. The key parameters governing this model are the network learning speed. This is a multiplier to the payoff that would give the value that you then ultimately add to the link weight after each interaction. We kept this standard at 1 throughout our simulations. Network discount, which is a certain percentage of the link weight that is lost after each round. So this sort of represents agent forgetfulness, and this has been shown to be an important thing to include that's realistic for human learning. So we discount 1% of the existing link weights at the end of each round. The imitation rate, which we keep at 1%, the independent probability that each agent considers imitating at the end of the round. So on average, agents will consider imitating 1 out of 100 rounds, but they won't necessarily imitate each of those times. And then memory, this is the amount of previous rounds that an agent tracks their payoffs for, and we keep this to 1. So when the imitation comparison is occurring, if an agent has received a higher average payoff in that previous round that they're considering imitating, they will imitate them. Now to look at some results from our model, we see that despite the fact that the social strategy is dominant and that social agents can learn to play other social agents over a wide range of parameter values, spiteful behavior still becomes the population norm. So looking at figure A, what this shows is the y-axis is the proportion of spiteful agents at the final time step of the model, and then the model is varied over different population sizes and different B over C values. Here we fix B plus C to equal 1, and so as B over C grows larger, the B value is getting closer and closer to the maximum payoff, and that's the payoff that the spiteful agent receives, and the C value is getting closer and closer to 0. That would be the payoff that a social agent receives in a mixed strategy type interaction. And so this is reducing the cost that the spiteful agent pays and increasing the harm they inflict. And so if this value is sufficiently large, spite will become the norm in the population. B shows us varying over different imitation rates, and again, basically the same outcome. If the B over C value is large enough, then spite becomes the norm in the population. Moving to figure C, this shows the proportion of each of the 4 different visitor-host interaction pairings that can occur over time in our model, and they're plotted individually by seed. So the green and blue lines are cases where someone is choosing to visit a social agent, and the red and purple lines are where someone is choosing to visit a spiteful agent. An important thing to note from what we had talked about earlier when we said that no matter what strategy my opponent or interaction partner chooses, I want to choose a social strategy. Well, the flip of that is also important to think about. No matter what strategy I'm playing, I want to play a social agent because that will provide me the highest possible payoff. And so that's what's occurring. No matter what the strategy type of the agent is, they're learning that they want to target playing other social agents. And so that's green and blue going up. Figure D shows the median average payoff for each of the strategy types over time in the model. And the purple line shows that spiteful agents are very quickly learning that they want to play other social agents, and other social agents are learning, hey, I want to avoid playing these spiteful agents, and the spiteful payoff eventually plateaus there at the payoff of B. So what's happening is the spiteful agent is being given one opportunity to visit another agent in the round. They're visiting a social agent, receiving a payoff of B, and no one is choosing them. So that's them sort of reaching their maximum possible average payoff relatively quickly in the model. When you look at figure E, This is sort of one of the key results of the model, and this shows the correlation levels by individual strategy type as well as the overall correlation level in the model. Green shows the correlation levels for social agents, and over the time period of the model, they become increasingly positive. And this is showing that social agents want to play other social agents, and so they're forming a positive correlation. At the same time, spiteful agents also learn that they want to play social agents, and so they're forming anti-correlation, and so they're getting negative values for their correlation. But because both these processes are happening at the same time, overall correlation doesn't change that much because it's being offset by the two opposing forces for the individual strategy types. So when we look at E, we're still at a B over C value that's low enough that spite isn't emerging in the population. But if we move to F, what happens is the extent of this positive and negative correlation both happen to an even greater extent because now the payoff, the B payoff that a spiteful agent receives is even larger. And so it's more quickly reinforcing its links to the other social agents that it wants to play. And the same thing for social agents. And so both of these correlations are happening to a greater extent. Overall, it's still relatively neutral. But you can see what happens when this B over C value is large enough is that the proportion of overall spite here in red eventually goes to 1 in the model. And it's interesting to note that this proportion of spite at first drops because, as we remember, whenever random interactions happen, the social outcome is favored. So at first, as agents are just moving away from random mixing towards more purposeful interactions through reinforcement learning, at first, the number of spiteful agents is dropping. Another aspect of the graph that I want to draw attention to is the dashed black line. This gives Hamilton's threshold, which was the previously accepted minimum amount of overall population anti-correlation that was thought to be needed to produce a spiteful outcome. In our case, you can see that the anti-correlation between spiteful agents at its minimum point does drop below this threshold, but our overall correlation does not come close to dropping below this threshold, even when we do see spiteful behavior become the norm in the population. So our results don't quite fit with the previous thinking in that regard. Finally here, I just want to summarize sort of the intuitive thinking of what's occurring in the model. So at the start of the model, both social and spiteful agents learn that they want to play other social agents. This means that over time, social agents begin to participate in a lot of interactions as many other agents choose to visit them. Some of those interactions will be with other social agents, which will provide a strong payoff of 1. But a lot of those interactions will be with spiteful agents, which will receive the much smaller payoff of C. This small payoff of C will eventually drag down the average payoff received by social agents, while spiteful agents will begin to participate in fewer and fewer interactions, and ultimately, in the extreme, participate in just one interaction where they're choosing to visit a social agent receiving a payoff of B. And so if the average payoff of social agents is dragged down enough, eventually they will look to imitate their spiteful counterparts. Finally here, we're going to summarize what we had just talked about. So our study shows that costly harm, aka spite, can spread through a population structured with preferential interaction and social imitation. We showed that anti-correlation for spiteful agents can exist alongside positive correlation for social agents. And this is a really interesting, important point that not a lot of models had previously thought about, that different strategy types may evolve different types of correlation simultaneously. And this provides an interesting new lens to look at real-world systems and models and think about what are the implications of this and what other systems might we see this type of contradicting correlated interactions. Thanks for listening to my presentation, and please feel free to reach out to me via email if you have any questions.